Welcome to the DIY Honda Garage channel. The DTC P0101 alert identifies an issue with the mass airflow MAF sensor's circuit range or its performance. The MAF sensor plays a crucial role in measuring the amount of air entering the engine, which the Engine Control Module, ECM, uses to calculate the optimal fuel-to-air ratio. This relationship is vital for efficient engine performance and emissions control. The MAF sensor is typically located near the air intake manifold, connected to the intake air duct. If this sensor is malfunctioning, it can lead to various engine performance issues and affect how the vehicle operates. After confirming the DTC, it is essential to cross-check for other related codes to ensure a comprehensive diagnostic approach. Always note any freeze frame data that can provide insights into the conditions under which the error occurred. DTC P0101 indicates a problem with the circuit range or performance of the mass airflow MAF sensor, which is integral to the vehicle's fuel management strategy. The MAF sensor is located between the air cleaner and the intake manifold, measuring the volume and density of air entering the engine. This information helps the Engine Control Module, ECM, to adjust the fuel injection timing and quantity accordingly. When the MAF sensor fails to perform within its specified range, it can trigger various performance issues, such as reduced engine power, poor fuel economy, or increased emissions. Additionally, improper functioning may indicate issues elsewhere in the air intake system, such as leaks or blockages. Therefore, effective troubleshooting requires first checking for any associated DTCs and confirming the conditions captured in the freeze frame data. The potential causes for DTC P0101 can include several factors that impede the functionality of the MAF sensor. First, poor electrical connections might disrupt the communication between the MAF sensor and the Engine Control Module, ECM, leading to inaccurate readings. Second, any damage to the intake air ducts, such as cracks, leaks, or loose fittings, can result in unmeasured air entering the system, skewing the MAF sensor's calculations. Third, a clogged or dirty air cleaner element can restrict airflow, causing poor performance of the MAF sensor and the engine overall. It is crucial to systematically check each of these components to ensure that they are in optimal condition before proceeding to more invasive testing of the sensor itself. When the DTC P0101 is triggered, drivers may experience a range of symptoms that indicate performance issues within the engine. Commonly observed symptoms include poor engine performance, which may manifest as hesitation during acceleration or overall sluggishness. Drivers may also notice an increase in fuel consumption, as the ECM may not be able to adjust fuel delivery accurately due to incorrect air measurements. The vehicle's check engine light will typically illuminate, alerting the driver to check for diagnostic trouble codes. Additionally, it might exhibit rough idling or stalling during low-speed driving. Recognizing these symptoms early can help prevent further damage to the engine and maintain vehicle efficiency. The first step in troubleshooting DTC P0101 involves conducting a thorough inspection of several critical components associated with the MAF sensor. Start by examining electrical connections for any signs of corrosion, loose terminals, or damaged wires that could disrupt the sensor's performance. Next, check the positive crankcase ventilation, PCV hose, intake air duct, air cleaner, and purge control solenoid, PCS, line for signs of wear or leaks. Any damaged component identified at this stage should be repaired or replaced accordingly. Reconfirm that these parts are in satisfactory condition, as this foundational check can often resolve the issue before delving into more complex diagnostics. The second troubleshooting step focuses on a visual inspection of the intake air duct to ensure that it is functioning correctly. Examine the air duct that connects the air cleaner to the engine to assess for any physical damage, such as cracks or breaks. Additionally, ensure that the duct is firmly connected and not loose, as any air leaks can cause improper readings by the MAF sensor. If the duct appears damaged or loose, it should be reconnected properly or replaced to restore the integrity of the air intake system. Conducting this check is essential because it can directly affect how air enters the engine and consequently how the MAF sensor measures that airflow. Step 3 involves checking the air cleaner element for dirt and blockages that could restrict airflow to the engine. A dirty air cleaner will significantly impact the MAF sensor's ability to function effectively, leading to inaccurate airflow measurements. Remove the air cleaner element and inspect it visually for any accumulation of dirt or particulate matter. If the element is found to be dirty or clogged, it should be replaced with a new one. Ensuring that the air intake is unobstructed is crucial for maintaining optimal engine performance and allows the MAF sensor to provide accurate input to the ECM. Moving to the fourth troubleshooting step, you will need to check the MAF sensor signal without the engine running. Start by turning the ignition switch to the lock position and then to the on second position. Utilize the Honda Diagnostics System, HDS, to check the MAF sensor's parameter values. The expected signal threshold should be about 0.2 grams per second, G-second. If the values displayed on the HDS align with this threshold, proceed to the next step. However, if they do not match, this inconsistency indicates a fault with the MAF sensor or the intake air temperature IAT sensor, necessitating their replacement to rectify the situation. In the fifth step, the engine must be started to check the MAF sensor's output while the vehicle is running. After starting the engine, vary the engine speed between 2,000 and 3,000 revolutions per minute, RPM. During this period, use the HDS to monitor the MAF sensor data list and check for any changes in the readings. If the MAF sensor reading does change in accordance with the variations in throttle position, this indicates that the MAF sensor is functioning correctly at this point. If no changes are noted, the sensor may still be at fault, suggesting the need for its replacement as indicated earlier in the diagnostic process. Step 6 calls for a more thorough examination of the MAF sensor while the engine operates at a stable speed of 3,000 RPM without load, either in park or neutral. This step requires that the radiator fan is allowed to operate and that the vehicle is driven briefly to gather data within the previously recorded parameters. The parameters to monitor include engine speed, vehicle speed, manifold absolute pressure, MAP sensor readings, and the throttle position TP sensor. After the test drive, the OBD status must be checked using the HDS to determine if DTC P0101 is still present. If the system records an error, it becomes necessary to replace either the MAF sensor or the IAT sensor and verify that the repair resolves the issue. Accurate monitoring during this phase is important as it ensures that the MAF is performing as expected under various driving conditions. Final repair verification for DTC P0101 involves several critical steps to ensure that the repairs made were successful. Begin by resetting the Powertrain Control Module, PCM, using the HDS. This reset clears any stored codes and prepares the system for new data. Follow this by executing the PCM idle learn procedure, which helps the PCM recalibrate its parameters for optimal engine performance. After completing this procedure, it's essential to test drive the vehicle for several minutes, ensuring that the engine conditions remain within the previously monitored parameters. Monitoring the OBD status once more will confirm whether DTC P0101 reappears or if the system clears successfully. A check for confirmed codes or pending codes should be performed to ascertain the efficacy of the repair work. Preventive maintenance is vital for avoiding DTC P0101 in the future. Regularly checking and replacing the air cleaner element will help prevent airflow restrictions that could impair the MAF sensor's functionality. It is also advisable to inspect intake ducts on a monthly basis for signs of wear, damage, or looseness. Keeping an eye on electrical connections to the MAF sensor and the PCM can preemptively identify potential issues before they escalate into larger problems. By implementing these maintenance measures, vehicle owners can enhance engine performance and prolong the lifespan of both the MAF sensor and the engine. Proactive care can ultimately lead to better fuel efficiency and reduced emissions. In conclusion, addressing DTC P0101 involves understanding the pivotal role of the MAF sensor and other related components in your vehicle. Record keeping during diagnosis, including freeze-frame data and associated DTCs, is imperative for a comprehensive understanding of the fault. Each troubleshooting step aims to isolate various potential issues, including physical inspections and sensor checks, ensuring that repairs are thorough and effective. Incorporating preventive maintenance routines can mitigate the risk of recurrence. Ultimately, accurate diagnostics and consistent maintenance practices are crucial for optimal vehicle performance and reliability. Please like and subscribe to the channel. See you next time.